Hello, this theory part at all sir is covered, I think. So we can start from first results onwards. So first procedure is you have to generate the frequency response of uncompensated linear system. And that is in open loop transformation only you have to do. So you have to generate a linear system open loop response. So this system is actually non-linear and you are linearizing the system. This is a non-linear equation. This is also non-linear equation. And you are linearizing the system. So whatever you done for the small signal analysis, same small signal analysis using for linearizing. And with that linearizing system, you will get the open loop transformation as equation 37. So the open loop transformation of the system consisting of this Ka is the servo amplifier gain and the linearized spool valve dynamical equation is this one. This spool valve dynamical equation. And this one is LVDT, that sensor plus the demodulator circuit. That system is this one. And the hydraulic actuator and other system is this GPA. So this whole things consisting of open loop transformation. So you are studied about Bode response. So Bode response is drawing for a open loop system and you are predicting the closed loop stability or all other things. Same way, this GP also you are predicting the stability and other things. That is why you are taking the linearized model open loop transformation. And the open loop transformation, these parameters are entering. You will get the open loop transformation of the system as it is. Equation number 18, this is 17 only. This equation number 18 you will get. So equation number 18, you can either directly you can enter these things in MATLAB and you can use Bode of this GP to plot the open loop uncompensated transformation. Uncompensated open loop transformation you will get it. So then comes 4.2 is compensator design. So in this compensator is actually a PI controller. So this is the PI controller. Gain plus K by S. This PI controller. And this one is a notch filter. And this one is for all of. So there is a hydraulic resonance is there. Hydraulic resonance is coming around some 37 point some hertz. So that time the response will be having a peak like this. So this time this peaking will happen. So you have to notch it out. That is why you are using a notch filter. This notch filter is just like this. This will compensate for this one. So the peak will reduce and it will be a smooth line. That is why this notch filter is using and PI controller is your controller. And this roll of things are using for that purpose. So that is the compensator design for the system. And this compensator value linear system and the non-linear system it will vary. For linear system, you have to use for this one only. For non-linear system, the parameters are varying somewhat. So you are tuning that compensator also. So the tuned value for non-linear system is this one. Equation number 21 is for non-linear system and equation number 20 is for linear system. So linear system compensator is this one and non-linear system compensator is equation number 21. So first one you have to do, either you have to enter these things in MATLAB file and you can use body, then you will get body. Otherwise you can make each and every one each block. So that first one is first block, second one is second block, and third one is third block. And you can use that these things to plot the border response. Otherwise, you can enter these things as a trans function and put it in MATLAB, and body of that system will give you the first was the answer. So the second one is compensator design only. And first of all, you have to enter these parameters in the table number 1 as a .m file. So you have to enter all the things like this only. Somewhere it is milliampere like things. This unit is milliampere only. So you need not worry about this thing. You need not convert these things into amperes. This is current limiter, amplifier, current limiter, those things. So these things are you enter as it is. So first of all, you enter these things as a script file and do it the first part of the exercise. Generate the frequency response of uncompensated linear system open loop trans function. And we can generate the frequency response of linear compensated open loop trans function. This first part also you can do it today. These two things only today I will take because tomorrow you are having exam. So first of all, you enter these values, enter these parameter values, and do the first thing. Body of these things will give you uncompensated open loop trans function. Then you have to do for compensator. Compensator value is this one only. After doing this one, you just ping me. So if you are completed this one, first part, the GP of S. So you will get a border response that is called uncompensated open loop system trans function border block. So now you have to move to this compensator design. And this compensator for linear system is you have to use equation number 20. So again, this earlier you are done that three trans function 1, TF2, these three are cascaded and you will get the open loop uncompensated open loop trans function whatever. So now you have to incorporate this compensator. So the compensator trans function is equation number 20. So equation number 20, you have to incorporate here and you have to plot the body of this whole thing. This also open loop only. So that is called compensated open loop trans function. So that is the first part of second question. Generate the frequency response of linear compensated open loop transformation. So this one also you do it today. So that compensator transformation, the compensator equation is 20. Again, you have to cascade that with the open loop transformation system. You will get linear compensated open loop transformation. And you enter these parameter values also. So this one is uncompensated linear open loop transformation response. Hello.
Yes, sir.
Yes, sir.
So like that you are getting.
So the phase response is different.
Yeah, this is compensated linear open loop transformation response.
Yes, sir. This one is
Yeah.
same.
So then
Yes, sir. Same.
yeah, then in the closed loop transformation you can do it next week. If you are getting these two values, then it is okay. This is for closed loop transfer function only. No, you have to check it, these things. Yeah, these values I will tell you later. This minus 3 dB and minus 90 degree values for closed loop transfer functions. So like this you are getting, then it is okay. That if it is in closed loop, the system will be stable. That we can do it in next. So either you can do it this way in MATLAB, or this way in MATLAB also you can do it. Otherwise you can do it in Simulink also. Both the cases result will be same. So if we are done up to this, you can leave. Tomorrow we are having exam. So
Yes.
next Friday we can meet. So next Friday we can complete the half this portion. This closed loop transfer function, the step response things, and one more week it will take for nonlinear frequency response. That time you bring your that seep.m and this DTFA files, this seep the command generator and nonlinear frequency response that you have done previously. These files you bring it with you. So from that file only you are generating all these steps. And one more thing, 100% command amplitude is 30 degree only here. So corresponding to that 30 degree, this maximum deflection value is 32 degree, and you are applying 30 degree only. This maximum deflection corresponding to 10 volt. So that amplitude will be changing. 30 is you are giving. So this ratio you have to give it in the seep generation. So this maximum deflection is 32.5 degree only is given. We are using it as 30 degree, 100% command amplitude. So these things you keep in mind. So this up to this we can cover next week, and this portion we can cover it in last week of April. And you will get one more week for submitting these things. You study these things thoroughly. I think first week of May the exam will be there. Second week onwards your regular exam will start now after second week.
Yes, sir.
So first week itself we will conduct exam. Before that you prepare these things and submit these reports. Up
So
to
this
date.
margin and bandwidth values have to be found for closed loop transfer function, right?
Yeah, yeah.
Okay.
So these things we can cover next week. Can start closed loop things and non-linear things. Next week we will start, and 30th up to 30 we can complete these things. One more week you will get it for examination. So you start preparing this lab reports itself. So after exam you started. Otherwise last you will have so many assignments and other things. So within 2 weeks this we can complete, and after that exam will be there. So tomorrow you are having exam, so today you can leave.
So
Yeah.
this, as you have said, that we have to give 30-degree maximum command amplitude. So accordingly, that parameter THF max value, which was set as 32.5 as a factor,
Yeah,
so
yeah,
we'll have
that
to change.
32.5 degree corresponding to 10 volt. So
Okay.
this one will be 9.23 something like that only, 30 degree corresponding. That value you can change it in that a amplitude in that seep generation itself, 100%.
Okay.
So that I will tell you when that portion is covering.